Hello everyone, this time this is lesson 3.9. Make decisions based on given information. Sorry. For the notes, this is on page 77 of your notebook. These are the information that you need. Okay? Read this. There's 1, 2. Decision rule based on Z values. And there's 2 of them. This is number 1. This is number 2. If P is less than or equal to alpha, then reject the null hypothesis. This is a null hypothesis. If P is less than, if P is less than or equal to alpha, then reject the null hypothesis. If P is greater than alpha, then fail to reject the null hypothesis. Fail to reject means do not reject. So do not reject means accept. So meaning, in other words, accept the null hypothesis. Alright? And then another one here. Another way, if you don't want that, you can also use this depending on the given. If the test statistics fails within the critical region, then reject the null hypothesis. Or if the test statistics does not fall within the critical region, meaning it's outside the critical region, fail to reject the null hypothesis, meaning accept the null hypothesis. So that's 1, based on Z values. Now the second is a decision rule based on T values. Left-tailed. If the test is left-tailed, then you use this. If T is less than the negative T value, then reject the null hypothesis. If T is greater than the negative of T value, then fail to reject the null hypothesis. That's for the left-tailed. For the right-tailed, if T is greater than T value, then reject the null. If T is less than the T value, then fail to reject the null. It means accept the null hypothesis. That's the meaning of that. Then if it's two-tailed, if T is greater than the T value, or T is less than negative T value, then reject the null hypothesis. If T is in between negative T value and positive T value, then fail to reject the null hypothesis. It means accept the null hypothesis. Alright? Okay. Example number 1. Here's example number 1. Find the P value for left-tailed hypothesis test. So we have here very important word, left-tailed hypothesis test. So take note of that. With test statistics of Z equals 0.59. So because it's asking for Z, we will use the table, the Z table. That's a positive Z table. 0.59. Okay, Z table. Okay, here's our Z table. 0.5 here, and then look for 0.09. So it's right here. So that's our value, 0.7224. So it means that we're gonna do the left tail test, and we will be looking the phi value, meaning the area from the table. So you get this table, 0.5, the first digit will be right here, and then the second digit you look up, the ending is 9, so therefore 0.09, the intersection is 0.7224, so meaning our p-value is equal to 0.7224. So that's how you find the p-value for a left-tailed test, left-tailed hypothesis test. So for now, the second, find the p-value for two-tailed hypothesis test, hypothesis test with z equals negative 1.87. So what do we have here? We have two-tailed, and then we have a p-value which is, because it's two-tailed, so 2 times the area, of course, we're from the table. Okay, so it's negative 1.87, and we want a z table for this, a negative z table. We have two negative z tables, so we will be going negative 1.8 and then 7, 1.87, so it's right here, negative 1.8 is right here, and then 7, so we'll be getting 0.037. So our p-value will be, so the p-value will be 2 times, so 2 times the area, which was 0.0307. So let's multiply that. 2 times 0.0307, and that is 0.614. So 0.0614. So this is the p-value for a two-tailed test with z equals negative 1.87. Okay, and then number 3, one more example. We're gonna have to find if it's right-tailed hypothesis test with z equals 2.34. Okay, so find the p-value for the right-tailed test, right-tailed hypothesis test with a z statistics, with a test statistics of z equals 2.34. So this is our test statistics, and we're looking for the probability value for a right-tailed hypothesis test. So what do we have? So we have two tailed test, and we have a p-value. Because it's a p-value, I mean, it's a right-tailed, so it's to the extreme right, so meaning all the way from the left, which is 1, the whole area is 1 minus the area from the table. The area from the table. It's like this. Let's say, for example, you're here. So meaning all of this is all of this is 1. The whole bell curve is 1. So 1 minus all of this. Then you get this part. Okay, 1 minus this part. Then you're looking for this equals this part right here. Okay, so to do that, you're going to go to your z table 2.34, and your z table, the positive z table 2.34, and 2.34 is this 2.34, 2.3, and then 2.34 is this one. So it means that your p-value is equal to 1 minus 0.9904, and that is equal to 0.0096. Okay, so that's how you find the p-value. Then the next video I'm going to show you is how to make decision based on the p-value. Okay, thank you.